Hey, morning, guys. I had to take a personal day, so I'm not in the building today. So you're just gonna watch this little video on. Just gonna do a short little video and some notes here. I'm not gonna do all of what I've done if I was in the classroom. And then you guys are just gonna try a couple examples that are similar to this, and then that's gonna be it. Okay. And then look forward to seeing you guys back. A lot of you guys back in the building on Monday. All right. So a lot of what we're going to do right here is exactly what we've done in the previous thing, where we're going to look at, we're still going to do graphing. Actually, section's called really creative. It's called more graphing. All right. And what we're going to do is we're going to look at the graph of the derivative. So this right here is the graph of the derivative. And we're going to use the graph of the derivative to answer questions about the original function. All right. So this is the graph of the derivative. We're going to answer questions about the original. And you can see the same questions we've seen before: increasing, decreasing, relative max and mins, concave up, concave down, and points of inflection. The difference is we are not looking at the original function. We're looking at the graph of the derivative. Now, the first thing that we are going to do is we're going to mark up this graph. Now, we're going to mark it with either first thing is either where it's increasing or decreasing. Now, this is kind of like our number line that we had before, and we were labeled positive and negative. Now, remember, where the first derivative was positive, that's where the original was increasing. So positive means wherever the y value is above, where everything is, the y value is positive, right? Well, where's the y value positive? Wherever the graph is above the x-axis. So what I'm going to do is anywhere that's above the x-axis, I'm going to label as increasing. All right, so this part of the graph right here is going to be increasing. This part right there, that's the part of the graph that is above the x-axis. Now, everything below, that means its y value is negative. That means the first derivative is negative, which means if the first derivative is negative, the original is decreasing. And you could go and fill in these intervals in a second, but I'm just going to mark up the graph first, and then we're going to answer the questions. All right. So then the next thing that we're going to talk about is concavity. All right. Now, concavity had to do with the second derivative. And wherever the second derivative was positive, it was concave up. Wherever the second derivative was negative, it was concave down. Well, this isn't the second derivative. This is the first derivative. But the second derivative is the derivative of the derivative, right? So remember, the definition of derivative is the slope of the tangent line. So the slope of these tangent lines right here would give you where the second derivative is negative or positive. So real simple. You're going to trace the first derivative, and wherever it is going down or decreasing, the actual graph itself, all right, not these things increasing and decreasing, where the graph itself is decreasing, that means concave down. So I'm just going to trace the graph. That's down. Then I'm starting to go up. That means the original is concave up. Up. That's down. And that's down. And the reason that is because the slope of the derivative is the second derivative. So the slope here is negative, which means the second derivative would be negative here, which means it'd be concave down. All right. So just to recap real quick, anything that's above the x-axis, where the graph is above the x-axis, we label as increasing. Wherever it's below the x-axis, we label decreasing. Then to do concavity, we trace the derivative graph. Wherever it's going down, that means the original is concave down. Wherever it's going up, that's where it's concave up, down, down. So to write our answers, now we just look at the graph. Where is the intervals where it's increasing? Well, it's increasing right here. So that's negative infinity to negative 3. All right. Starts again here to here. Union, negative 1 to 1. All right. Where was it decreasing? It was decreasing from negative 3 to negative 1. Union 1 to infinity. All right, good. All right, to figure out relative max and mins. All right, maxes and mins is where it changed from increasing to decreasing. Well, where do things change from increasing to decreasing or decreasing to increasing? It happens at where it crosses the x-axis. All right, so at negative 3, it goes from increasing to decreasing. Something's increasing to decreasing, that is a max. So at -3, we have a max. At -1, it goes from decreasing to increasing. That's going to be a min. So at -1, and then it goes from increasing to decreasing. Remember, increasing to decreasing is a max. Notice it just says the x coordinate. So I don't have to find the y. To find the y, you normally plug back into the original. You can't plug back into the original because there is no original. So you just have to list the x coordinates. All right, so now for concave up, we just look at the interval. Where was it up? Well, it's up from here to here. Remember, it's the x value. So the x value here is -2 to 0. It's not the y values. It's not -3. It's -2 right here. So it's concave up from -2 to 0, right? So reading this is just like reading the number line. The x values are what we're using as our intervals. And let's see, that's the only place it's up. So that's it. Concave down from -infinity to -2, union 0 to infinity. All right, now points of inflection are places where it changes concavity. So it changes here, it went from down to up, and from here. So basically that's going to be peaks and valleys, and you only have to put the x coordinate, so -2 and 0. So you look for peaks and valley on the interval, on the graph of the derivative. All right, and there you go. That's what we have for that. Okay. All right, this one. All right, so we have an asymptote on here on the graph of the derivative. However, notice it says that f of x is continuous. That means this asymptote is not really in play on the original. So this asymptote is only on this graph. It's not on the original because it says it's continuous. The original is continuous. So I go and mark anywhere that is above the x-axis is increasing. Anything that is below is decreasing. Then I go and trace the graph. Wherever it's going down, that's where the original is concave down. Down, down, still down. Now it's going up, up, and up. All right. Now, once we've done that, we go back and look at the graph. Where is it increasing? It was increasing from -2, increase to 0, and then union 4 to infinity. All right. It is decreasing here from negative. It's not -infinity. It's -4 to -2. Union 0 to 2. Right. Maxes and mins. Normally it's where it crosses the x-axis. This was a special case. Do you see how it goes from decreasing to increasing right here? Normally you're like, oh, well, that's an asymptote. However, it's not on the original. So it does change at -2 from decreasing to increasing, which makes that a min. So at -2, 0, it goes from increasing to decreasing, which is a max. And here at 4, it goes from decreasing to increasing, which is a min. So that is 4. So now we go concavity. Where is it concave up? Well, it doesn't go concave up until right here. It goes from 2 to infinity. Concave down is from -4 down to -2. Now you're like, well, don't I have to break up the asymptote? But remember, that asymptote is not in the original. These are all answers about the original. Points of inflection are at peaks and valleys. The only place it changes from down to up is right here at 2. And there you go. All right. All right. Now, the last one we're going to go over, this one says we have an asymptote, but this is saying that f of x is not continuous, right? This is not continuous, which means that this asymptote will also be on the original, right? It will also be on the original. So let me go mark this up. Increasing, 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 decreasing, and this is all decreasing down here. All right. Now we trace it up, up. Now I'm going down, so that means the original is concave down, and this is all going down. I trace this. This is down. That goes up. And now we just write our intervals in. Where is it increasing? -4. So from here to here, which is -2. Union from -2 to infinity. All right, because all this is above there. So it's all increasing. Sorry, I don't know what's happening here with my mouse at home here. Decreasing, -infinity to -4. Union, where is it below? -2 to 1. Oh, let's just realize that. Here, I made a mistake here. This is 1, not, I don't know why I wrote -2. Oh, you know what I did? I looked up here. I'm an idiot. So that should be a +1 right there. It's +1 to infinity. My fault, not -2. Sorry about that. All right, so relative max or mins, where does it change? All right, well, it changes. Let me change the marker here. All right, it changes right here, decreasing to increasing. Decrease and increasing is a min. So at -4, changes here at -2. But that is a max, goes from increasing to decreasing. All right, you can't have a point on an asymptote, so even though it changed from decreasing to increasing, can't happen. So these are only 2 plots, the only places it happens. All right, concave up, let's see, -infinity, and it changes here, which is 3. These are all concave down, down, and then from, what is that, 2 to infinity. All right, where is it concave down? It's concave down from -3 to 1. Now, it does continue to be concave down until 2, but the asymptote, it's not continuous, which means that's on the original. The original also has an asymptote, so I have to break this up and put from 1 to 2. And then points of inflection, peaks and valleys, here and here. So at -3 and +2, we have points of inflection. All right. So it's all about, once you just mark up the graph and know how to mark up the graph, over here becomes relatively easy. All right. So I'm going to give you like 1 or 2 to try to submit by next week, and then by Monday, and then we'll go over this again, and then do something else as well. All right. I hope you guys have a great weekend, and I'll talk to you